Good morning all. My name is Alex, and in this video I'm excited to talk about Azure Unreal Pixel Streaming and the application of different Copilot scenarios using generative AI models in Azure. So let's look at this diagram here. So we've spent a lot of time covering different embodied AI concepts on medium.com, which relate to metaverse and application of AI, and specifically generative AI and Copilot scenarios. So today I'm excited to talk about how this applies to high fidelity, high definition, rich visualization that can be delivered for immersive experiences by Azure Unreal Pixel Streaming, when you essentially have an Unreal package that you're able to run with the GPU compute of Azure in Microsoft Cloud, and then deliver this to your web browser on any device with a connection. So if you look at the breakdown here, just coming from, again, the perspective of embodied AI and application of AI for different scenarios for metaverse, so we divided this into metaverse as well as AI. So metaverse specifically, we're focusing on immersive experiences. And again, as I mentioned, technology behind the presentation today is Azure Unreal Pixel Streaming using GPU compute and Microsoft Azure Cloud. If you combine this with AI, specifically with the generative AI copilots based on Azure OpenAI GPT-4 models and Azure Speech SDK, you actually have a full package, which includes the video, sound, natural language, and speech. So, for example, your experience can see and hear, understand, and speak. Basically, on this diagram, we try to explain kind of in a few words how this manifests itself. So in this case, we have a web browser in which you're experiencing an immersive experience. In this case, this is just a simple template of a third-person Unreal template. And Azure Unreal Pixel Streaming is capable of delivering a video as well as the sound. And then you can also do a very creative application of different kinds of commands. So for example, some of the commands may be inside of Unreal, just like that blue pin on the left-hand side. And then, for example, as simple as like you move in on your device of your choice inside of this immersive experiences, pixel streamed from the Unreal Azure GPU compute backend into your device, and then you I don't know, arrive at that location. For example, there is a trigger box that triggers some behavior in the Unreal game, and it's just a regular Unreal mechanics driven by blueprints, for example. Or you can also have elements that are driven by and commands driven by a website, a web page itself. Like, for example, down at the bottom, we have the website commands, emit command, emit UI interaction commands. And also you can do any kinds of web API calls, right? Because ultimately we are capable of overriding some logic on the player, on the player layer of the user interface of that web page. And then we can trigger commands towards Unreal from the web page itself. And some applications could be, again, you may want to move around your experience just by, what you see in the lower left corner, just like by placing some pins and then invoking those commands from the web browser. Or you may want to do a full Copilot, like a speech interaction with, like, speaking with your GPT-4 Azure OpenAI backend, asking free-form questions, getting the free-form answers for the areas of your interest, or tweaking and tailoring your assistant on the backend to be a specific and concrete assistant for a specific area. For example, it could be like helping you navigate through your 3D space and knowing the context of what this game is all about. And then also with the capability, so this is just a regular kind of the GPT-4 became and capabilities of natural language understanding, intent recognition, and asking and answering questions became commodity very quickly. It's amazing. But then with the recent release and availability of GPT-4 with vision models, which is currently in preview by OpenAI, you can actually explain what's happening on the screen. This is truly exciting. So just delineating between like DALL-E models generating images from the prompt versus GPT-4 with vision, which is truly like tailored towards explaining, like you can submit an image and then it's truly like a multi-modality explanation like you get with the submission of your image. You can say you can provide a prompt saying like what's on that image, and then it will explain for you what's happening in the context of your game. So let's just take a look very quickly from the concept towards implementation. So how we technically implemented this solution. So from the Azure Speech SDK perspective, you can learn about this on the web page right here, what Speech SDK and what languages it supports. And obviously we're interested in JavaScript in the browser for our example. And then you can find this kind of minified version of the JavaScript distribution of the Speech SDK that you can plug in for your website. And this way, again, you will see in the further demo how we implemented this component, which takes care of the text-to-speech, TTS, and speech-to-text, STT, using Azure Speech SDK, excuse me, integrated with Azure Unreal Pixel Streaming user interface. And then when it comes to customizations in general of the user interface, we have two approaches. One approach is more modern, and you can find this here. So basically, the front-end project that Epic Games provided for customizing player web page, and you can find all of this information in here. It's a TypeScript project that allows you to customize the signaling server components of the user interface properly, as well as other components as well. This is where you can find all of this information. And then there's information about customizing player web page, and obviously you can see like how you do it by means of TypeScript. But for the marketplace deployment item for Azure Unreal Pixel Streaming, it's actually compatible with both Unreal 4 and Unreal 5, including the latest Unreal 5.3.2 at the time of this recording. What this means is that it implements what's called the monolithic JavaScript files implementation. So we will be customizing, you will see we'll be customizing the app.js for the most part, and the player.html. So this is just described here, and the reason, the foundation of kind of this decision is described here. So I just wanted to make sure that it's clear that there's a new way, there's an old way, and the current Azure Unreal Marketplace item, because it supports 4 and 5 versions of Unreal, it implements the monolithic JavaScript files, and this is how we'll be customizing it. So we covered this. The last piece here, I'll get to the detail of this in Unreal itself, but the way we invoke commands is described very well in here. So this allow pixel streaming commands flag has to be set. This is done by the configuration of the Azure Unreal Pixel Streaming Marketplace item via like a one checkbox that I will refer to. And then ultimately, all of those commands, we use the emit UI interaction interface and the function to call it. And you will see how like this my custom command was implemented. And on the back end of Unreal in the package, there's a blueprint, the third person character blueprint that implements this approach. You'll see this more detail when we get to Unreal. And then ultimately, if you're interested in learning about GPT-4 and consumption of that through Azure OpenAI, you can learn about this here. And then the final thing about the GPT-4 with Vision, recent release by OpenAI. So just to make that distinction very clear, so we use the GPT-4 Vision preview model right now that you have to have a credit on your account with OpenAI, with the Plus account on OpenAI to have access to this in preview. And then recently, this model became available as an API. So basically, to call this, it's pretty pretty easy to call. You can start with the simple postman, and then you can just turn this into the JavaScript implementation. This is what we did for this customization. And this can take an image URL, or it can take a base64 implementation, base64 representation of an image. And for our scenario, because we're taking a screenshot of the video streaming page essentially and sending that, so we implemented the base64 representation of an image, which is very easy and straightforward and explained here in much detail. And then also just to make sure that we understand that piece, there are multiple models available, like GPT-4 family of the models. So that's exactly the model we used for GPT-4 with vision. And then, as I mentioned before, DALL-E family of models is tailored towards generating images with the textual prompt. And for our example, we exactly need a GPT-4 with vision, which is tailored towards providing an image and then explaining that image in the form of a text, for example, or leveraging its multimodality features. Yeah, let's see how this is all working. All right, so what you will see is the following. For more, stay tuned. So I'll just explain what's happening on the screen right now.
A humanoid robot in a virtual environment with tiled surfaces.
All right, so this is using the newest GPT-4 with the vision model, interpreting what we're seeing on the screen inside of Azure Unreal Pixel Streaming. Stay tuned. All right, so let's take a look at how we deploy the Azure Unreal Pixel Streaming marketplace item. In order to enable customization of your user interface and the player page in particular, when you deploy the Unreal Azure Pixel Streaming marketplace item, you have to specify what package is being deployed, obviously, that contains those customizations. And then you also have to specify, check this check mark, says I have made customization modifications to the matchmaking and the signaling web servers. To get the package to begin with, you have to click on this button right here that says before making any customizations to matchmaker and signaling server, it's critical to download Azure modifications by clicking here. So you click here, which triggers a download. When you download, you will get this package, which is called Web Servers _ Marketplace, and the version. There's a README that you can open up, and you can see that README has the information about what the procedure is for modification and making your customizations. So read that, please. In the nutshell, you have, for example, for us, it's critical to be able to modify the signaling web server, and you basically have a player HTML here, and then you have a monoscript for app.js right here. So we will be looking at this file mostly, and at this file. Also notice there's like a login page if you enable authentication on your signaling server, and for that aspect, I will have another video that goes into the details about deploying Azure Unreal Pixel Streaming securely. So check that out later. Right now, we understand what this is. Let's look at the Visual Studio Code very quickly to understand what's inside of app.js and the player HTML. So player HTML, just an HTML. So if you want to, like, for example, include the distribution of your speech SDK, minified speech SDK, you would do it right here. That's what we did. So basically, depending on the structure. And then also, there's a bunch of stuff in here that basically displays different elements of this interface. And if I just open this up, you will see that what we see in Pixel Streaming user interface, when you click on plus and expand that, you will see all of this user interface displayed. And I even have a web server that I can actually like test, make modifications and test with a plugin for a live testing for the HTML. I can do it right here in the convenience of my Visual Studio Code. That's how I develop. So yeah, basically like we would do another button. You will see this in the demo. And then ultimately, there's a section here that sets up HTML events. And HTML events, basically, if you look at that last button that was about the latency test, this is what this is. So we can expand this to get access to the button and specify an event handler for on-click, and then say, for example, emit UI interaction, and then my custom command in double quotes. This is what will send that command to the Unreal backend. So this is in a nutshell how you customize, and just to make it even more obvious how this looks like, we will look at the player HTML page, and you will see this plus and all of the buttons that we have, and this is how we can customize and make our elements of user interface available in the context of Azure Pixel Streaming. Now, there's a couple of more things that we have to cover here. So when we specify that explicitly made customizations, you would copy the contents of these folders after customization into the engine folder structure inside of your Unreal application that you packaged. This is how you make this available. And don't worry, like if you deploy multiple streams, don't worry, you have to copy this just once per instructions. And then if you have like 4 streams per VM, then it's going to be 4 copies of that signaling server. The same customization gets copied multiple times. So that's done for you automatically. Now let's look at another aspect which is important. So you also have to make sure that this enable allow pixel streaming commands option is ticked. And then also a quick comment about HTTPS. So for example, to be able to successfully use Azure Speech SDK, you will have to enable HTTPS, which is again another video that I will have on this topic, how to enable a secure deployment of Azure Unreal Pixel Streaming. So just to close the loop on this one, if we look on the back end, what this means, this is just setting up a flag, right? So remember this allow pixel streaming commands, and it has security implications because like when you do emit UI interaction or emit command, this is mandatory to have, otherwise like the interaction and communication will not happen. So if I go on the VM, and then if we look at first, let's look at that flag. So for example, this is my signaling server, and if I look at its actions here, the last parameter here set to true, that allows me to pass commands. And if I look at this last parameter is enable pixel streaming commands, which is boolean, false or true, and we set this up to true. And then also, as I said before, when the deployment happens, then you have, for example, in engine, source, programs, pixel streaming, web servers, and then signaling server, matchmaking server, you will have all of your customizations coming through appropriately. So all the stuff that you customized in player, .html, login.html, or anything else, including the app.js, will come through successfully, and this is how you enable your customizations in the nutshell. To enable pixel streaming commands from the deployment of Azure Unreal Pixel Streaming, we have to make some modifications to our Unreal package. Obviously, once we made the modifications, we have to export this package into the platform of our choice, which is the Windows platform here, with the project settings, with pixel streaming add-in, add-on enabled, and touch controls and other things per your preferences. But in this case, we want to take a look at how we enable the pixel streaming input from the website into the package. So I have this third-person template in which I have a sound as well as the controller. And then a good place, a recommended place for us to place our and enable our pixel streaming input will be in the character blueprint. For example, in this case, I have a third person character blueprint right here. So I'll open this up. And then what I have here is rather simple. So first of all, I added the pixel streaming input node in here. I can do it this way. Pixel streaming input, pixel streaming audio. Like in this case, I went with the pixel streaming input, and this ends up being displayed right here. And then after this, we basically added a logic to handle the input. So we have pixel streaming input going into the node which is called bind event to on input event. This binding happens at the time of event begin play. And then after this, basically the rest of the blueprint logic takes place, which I just basically interjected here with my binding. And then basically I define my custom command here. So I say the custom event. So you just basically add a custom event handler. And then I name this UI interaction. I specified that if the custom event happens, and the custom event is called my custom command, then execute this logic. And the logic consists of several steps. So we jump in, the character jumps. And then we also print the hello my custom command on the screen, so you can also see it clearly displayed that we took the command. And obviously you saw character jump in, which is the best confirmation that everything works. All right, so in this short demo, we'll show how we implemented a command from the web browser to the Unreal Engine to make the character jump. Let's get in. This is our character, and we will be able to see and navigate around the world. Our character is capable of jumping as well. So what we did here, we implemented a command, and this command is called Copilot test. And in this case, the only thing that Copilot is doing for us is sending a command from the web browser to Unreal Engine and makes our character jump. Let's see how this works. And you can see there's a hello my custom command, and we are able to jump by sending this command. Now let's take a quick look at how sound gets delivered through the Unreal into Azure Unreal Pixel Streaming. So in this case, we have a game, a template that we deployed through Pixel Streaming, and you can see that the sound is coming through properly. You can also see the sound control if you go right-click, show all commands, and then you'll see at the bottom, you'll see all of the commands here, and it shows the sound control as well. All right, next we took our scenario for Copilot forward and implemented a Copilot which is powered by Azure OpenAI GPT-4 models. Let's see how this works. So before we dive in, there are a couple of buttons here that we added. So this time it's a Copilot voice prompt and the GPT-4 with vision capability explaining what's on the screen. Let's see how this works. So I navigate to the space, and then I can have a conversation with my Copilot. So I will use Copilot voice prompt first. Right here, start voice command. When I do it, it's asking me in the web browser to use microphone and the permission to do so. So I'll just do it, allow. Hello, how you doing?
As an AI, I don't have personal feelings, but I'm here and ready to assist you. How can I help you navigate in the 3D world?
So in this case, the configuration for the Copilot behind the scenes using Azure OpenAI GPT-4 model is configured to help you navigate in the space, and it only knows about certain like handful of commands that it can help you with. So that's the tailored setup. And we saw how we enabled commands for like jumping for the character and so on. So this is a similar idea. Like you can have a free form discussion, or you can have more like tailored Copilot that is allowing you to navigate through, let's say, 3D space. So let me just ask a couple of more questions here. What commands do you know?
I know the following commands: left, right, forward, backward. These can be used individually or in combinations to navigate in the 3D space.
All right, that's pretty good. So again, it's the tailored Copilot that we're dealing with. And I can ask it like a random question, for example, and because of the configuration, it will act appropriately. So let me just do one more thing. Capital of France.
As an AI, I'm sorry, but I can't physically navigate you to the capital of France. However, I can tell you that the capital of France is Paris. If you need directions, I recommend using a GPS or a map.
That's pretty good. So it's trying to be helpful and still be on point for what it's configured for. All right, now let's take a look at the capability of uh, explanation for what we see on the screen with the help of GPT-4 with vision based on an OpenAI API. So we have this button here which is called GPT-4 Vision, and when I press this button, what's on the screen? The system is going to take essentially a screenshot of what we're looking at, submit this to OpenAI API for GPT-4 with vision, and get an explanation back about what we're seeing on the screen. Let's see how this works.
"3D rendered scene with a humanoid robot and a blue box in a grid environment."
That's pretty good. This is what it is. Here's the blue box in 3D environment and the humanoid. And then if I just navigate somewhere else, let's just stand here and ask again.
The image shows a 3D render of a humanoid robot in a simulated environment with a tiled ground and walls under a blue sky with clouds.
Awesome. That's very accurate. So you can only imagine how you can apply this in your scenarios, in your Copilot scenarios, along with the capabilities of Azure Speech SDK, which allows you to hear and speak, capabilities of GPT-4 family of models, basically allowing you understanding of the natural language, as well as the newest capability of GPT-4 with vision that allows you to explain what you see and make sense of it.